Anybody tell me? Oh, okay. So some of you have seen it, it seems. So what happens as a result? X gets what? X gets 1. That's right. So like printf, scanf also returns a value. And that number is equal to how many number of values we are reading through this particular scan. Okay. When I run this code, I'm going to read a number for y, and as a result, when I try to print the value of x, I get 1 because I am reading one number for variable y. So as a result, x gets 1, and that's how x is 1 and y is 45. Let's say we have another variable z, and we are trying to read two numbers, 1 into x, y, and 1 into z. And let us print the values of x, y, z in separate lines on C. So at this juncture, what happens is scanf first reads two values for x and y, and since scan returns whatever number of values read, x gets 2 into it. Please mute yourself, whoever it is.
తెలంగాణలో మరికొన్ని చోట్ల వేరే సిచ్యువేషన్ ఏర్పడింది. ఇంకా ఒక గంట సేపట్లో 4 రోజులకు సంబంధించి లాక్డౌన్ కాబట్టి దాదాపు ఎక్కడైతే నిత్యావసర దుకాణాలు కానీ లేకపోతే
I don't have rights to mute you. Please mute yourself. Thank you so much. Okay. So, since this scan is trying to read two values, x gets 2. That is what we are expecting. Let us see whether it is right or not. So I'm going to read 12 for y and 45 for z. And when I run the code, I get, when I press enter, I get 2 for x because I read two values, and 12 and 45 for y and z respectively. So altogether, scanf also can return values, and let me write it for you. Scanf returns the number of values or number of inputs read through it. Yeah, in the previous example, we were reading only one value, so it returned 1 to x. And now we are reading two values, so it returned 2 to x. So that is how scanf works. Okay. Now this is the intricacy of scanf statement. Now let me take you to more interesting part. There is a typical operator called increment operator, which can be written like if I have some value for x, let's say I have some 10 in the variable x, and when I write x plus plus, I think you know very well what it does. What it does?
Increment after x.
No surprise, right? It increments the value of it, right? Comma x. So when I does this, what happens is I get what? 11 or 10?
10.
That's the confusion everybody gets. 10, 11. Let me give you a clue. Writing x plus plus means x is equal to x plus 1. Now tell me what would be the possible output.
X is in increment, so 11.
So remember this point. Whenever we write x plus plus, it means that x is equal to x plus 1. Okay. So There is always a difference between writing. Please mute yourself, please. Now tell me what will be the output? 10 or 11?
10, ma'am.
10 or 11?
10, ma'am.
10, because we are not assigning that modified value, right? But what if we write like this? This itself internally means that x must be equal to whatever its value plus 1. So that is how we got 11. Okay, no confusion, right? Now let me change this style a bit and write this here. Can anybody tell me what will be the output?
11.
11? 10?
11.
Okay.
11, ma'am.
11, ma'am.
Okay, let me run the code now. Somebody said it is 10. 1253. It is 10. It is 10. Okay, because observe what I'm going to say now. Okay, just observe it. I told you about one of the mystic natures of printf. And I'm going to reveal another mystic nature of printf that, let me write it. Printf gets evaluated from right to left. If you remember, I already gave you this clue in the previous classes, but no problem if you don't remember it. So as a result, what happens? What if it gets evaluated from right to left? What makes the difference is, you all know that this is a post increment, right? Let me know if I need to revise post and pre increments or not. Does anybody need any quick revision on post increments? Post and pre increments.
Yes, ma'am.
Okay. So when I write some x is equal to 10 and write x plus plus, this is called post increment. Post increment. Okay. And when I write plus plus x, this is pre-increment. They both are going to mean same. What they mean is x is equal to x plus 1. Okay. So in both the cases, when x is equal to 10 and I say x plus plus, x becomes 11. And when x is equal to 10 and I say plus plus x, x becomes 11. So both are going to mean the same. But what makes the primary difference between pre-increment and post-increment is, so why this name? When x is incrementing itself, no matter post and pre-increment, then what makes the difference between calling them like pre-increment and post-increment? Observe this carefully. So Harshini, okay, good observation. So let us hold on this for our other friends also. The difference, can you please mute yourself, everybody? Difference comes when we try to assign this x to something else. Okay. Mute yourself, please. 418, 409, 4G3. Please mute yourself. 409 and 4G3. Good. Okay. So whenever you want to talk, unmute yourself, talk and immediately mute yourself, please. Okay. Now y is equal to plus x. I'm going to write. Okay. So this is post increment. This is pre-increment. So this step happens in 2 steps. This seems like single instruction, but this happens in 2 steps. The first step is x increments itself to 11, and then y gets the value of x, that is 11. Okay. Now let's come to post increment. This also happens in 2 steps. Since it is saying post increment, y takes the value of x first, that is 10, and then x gets incremented. X gets incremented to 11. If you observe, in both the cases, x is not changing, but the assigned y is changing. That makes the difference between pre-increment and post-increment. Now let me decode it once again. Pre-increment. So pre-increment means increment before assignment. Okay. Now post-increment. Post-increment means increment after assignment. So increment after assignment, you assign it and then increment. Post increment, increment after assignment. Pre-increment, increment before assignment. Got it? Everybody understood this, or you want me to give you another example?
Clear.
Clear? Okay, good. Now coming back to our question, here it is plus plus. It's a post increment. As a result, what happens is x gives its value here already. It gives a 10 and then it increments. Now next time when we try to print the value of x, there we can see the incremented value. When I run this code, then I can see the incremented value. Mute yourself, please. Okay, so printf evaluates expressions from right to left. What happens as a result is, when it sees x plus plus, since it is a post increment, x gives its value to this part, percentage d, that is 10, and then increments itself. X then increments. Post increment means increment after assignment. So x gives away its value here already, that is 10, and then it gets incremented, so that next time when you try to see the value of x, you get the incremented 11. Did you all understand this part?
Yes, ma'am.
Yes, ma'am.
Once can you repeat?
Understanding this part is very crucial. So we are going to go into the most trickier part. Are you ready?
Yes, ma'am.
Now, with the clues that I gave you already, that print happens from right to left, and the difference between pre and post increments, I want you people to work on this one. X plus plus. Okay. Predict the outputs. Ten and 11, somebody said. Bhanu. Okay, most of the
10,
people.
10.
10, 11, 10, 12, 10, 11. Very few people said 10, 12, but most of you people said 10, 11, and there is 10, 10 also. Let's see. Somebody said 11, 10. Okay. Let me run the code. It is 11, 10. 11, 10 because see this part. This is, I told you, right to left evaluation, right? So look at the rightmost x plus plus. With rightmost x plus plus, what happens is it has to give its value away. That is 10. So this percentage D gets 10. Let me take annotations. So this part is, since it is post increment, it is 10. So here we get 10. And don't forget, incrementation has to happen. So x becomes 11. After that, it comes here. By this time, we come here, x is already 11 and it is a post increment again. So first, that 11 is given to what? That means here 11 is given. And then since it is post increment, later x becomes a 12. If you try to print the value of x later here in this part, you get 12. So that's how for this part you get 10. And for this part you get 11. So 11 and 10. Clear, everyone?
Yes, ma'am.
Yes, ma'am.
If you have any doubts, please let me know.
Yes, ma'am.
Okay. Now let's move on. Let's make it a bit simpler now. Let me take pre-increment and let me take only one value and let print only one value, plus plus x. Now
11, ma'am.
11,
11.
11, okay, 11. Okay, that's a unanimous answer, 11. Yeah, since it is a pre-increment, x will increment first to 11 and that is presented on screen. Good, very good, very good. Moving on, let's try to print another value, which is another pre-increment of x itself. This time
12, 11.
12, 11, 12, 11.
Twelve,
12, 12, okay. 12, 11. Most of you people said yes. 12, 11,
11, 11, 11.
11, 11. Let's see. It is 12, 12. How 12, 12? Why not 12, 11? Why it is 12, 12 is you have to carefully observe, of course, it is dependent on compiler also sometimes, but why this time? Okay, as you said, 12, 11, most of the compilers give us this 12, 11, but why 12, 12 here is, if you aptly follow the precedence table, if you carefully observe the precedence table, pre-incrementation has got highest priority than post-incrementation. Normally, let us try to evaluate this one very normally. So coming here, since it is pre-increment, x gets incremented to 11 and that 11 must be given here, right? And then since it is another pre-increment, this 11 has to change to 12 and that 12 must be given here in the first percentage t. So as a result, we got to get a 12 and 11. Most of the compilers give you this kind of output. And when it is asked in the examination also, you have to give it like 12, 11 because that is what happened till now. But with the latest compilers and the exact precedence table, all pre-increments happen all at a time. All pre-increments happen all at a time. So as a result, what happens is, how many pre-increments are there here? There are 2 pre-increments. So x becomes 12 and then that 12 is given to each of these amount. Okay, so I don't want to confuse you with this annotations, please. No, don't do annotations, anybody. And so, okay, when it is asked in the examination, you have to give the answer like 12, 11, but this is with the very latest compilers. It happens like 12, 12. Don't bother about 12, 12 now. You can go with your 12, 11 answer. Okay, am I clear?
Yes, ma'am.
Okay. Now, moving on. This is about operators now. We're going to see the intricacies of the operators now. So x is equal to x divided by 2 and print the value of x. What do you expect?
5.
5.
Is that a question to ask? Okay, let me run. So it is 5, right? Good. Same kind of operation, division by 2, can be done with a right shift operator also. You see this operator? Did you ever see this operator?
Yes, ma'am.
When you right shift a particular operator by 1 bit, same thing happens. So when you want to divide it by 2, when you want to divide a number by 2, you better right shift it by 1 bit position. But why should we do it? You cannot see the results. Visible results are not possible here. But what happens here is, here everything happens at binary level. Whatever operations happen at binary level, they are far more quicker than the kind of operations that happen on decimal numbers. So this is just a clue to you. To sometimes when you write online coding parts, you get timeout problems, right? Time limit exceed problem. So that kind of situations, you can use this shifting operation instead of division operation directly. Now that is just for your programming sake. This is not a tidbit, but this is for your programming sake. Now let me move on and ask you a question like, if x is equal to 5. Print hello. Else print I. What would be the possible output?
Hi, ma'am.
Hi.
Hi, ma'am. Hi, ma'am.
Hi. Okay. I want everybody to answer this question. Somebody said hello, somebody said error, somebody said hi.
Hello.
So we have options hello, hi, and error.
Error, ma'am.
Error. Okay. Somebody asked some doubt about shift operator. I'm overpowered. Only for division by 2, yes. Only for division by 2 we can use it, but if you think it intelligently, you can use it for some more divisions also. We'll see that later when we'll get there when we get there, okay? Okay. So let us see what is the output. It is hello. Hello, because the first and foremost thing is somebody said error, right? No, that's not an error. Let me take you back to like 23. If 23, hello, else hi, what will be the answer? What will be the output, I mean?
Hello.
I wrote 23. Is that syntactically correct?
No, ma'am.
No, ma'am.
Okay. So most of you people are also answering like, yes, it is legal and it prints hello. Let me run the code and show you. Yes, it is legally correct. Because if you try to keenly observe the syntax of if, the syntax says if expression. You refer any textbook or any internet content, it says syntax part law, it says if expression. It won't say if condition. Anaru. They just mention like expression. That means any kind of valid expression is allowed to be written within the parenthesis of if. Okay. Now, since your 23 is a valid expression, 23 is syntactically correct. But why hello is, whenever if is given with direct condition, it can get true or false values from that. If it is given like 5 less than 6, you can easily come to a conclusion like whether this is true or false, right? But when I give something like 23 into 56, if I give this in the condition part, you get confused a bit, right? But what happens here is this 23 into 56 is evaluated to some x, whatever it is. So let's say some 234 ayindi anukunna. Then that 234 is a true. It is treated as true. Let me write the conventions that any non-zero is treated as true. 0 is treated as false. So this is the convention we have in the language, that any non-zero is treated as true. So 234 now gets evaluated to true. So since this is true, we get hello. Let me run the code. we get hello. But if I have 12 minus 12, if I have 12 minus 12, that gets evaluated. 12 minus 12 is 0, and 0 is treated as false. As a result, we must get high. Let's see. That is the result. The takeaway of this experiment is your if can take any valid expression and it tries to pull the Boolean value, that is true or false, out of that expression. Okay, so you need not to directly give a condition, but you can give any valid expression and that will be converted into true or false. Now, what about the negative values? Yeah, that's a good question. Let me give minus 12 and see what happens. So when we give minus 12, it is printing hello. I told you any non-zero includes negatives. Okay. Okay. Now, ma'am, previously you took x is equal to 5, then why is it in hello instead of it print hi? Okay. So we'll go back to that question. I wanted to build the blocks for you. Now let us go back to the previous question where we gave x is equal to 5. So this x is equal to 5 is a simple expression of assignment where x gets 5. So this whole expression is now converted to 5. 5 is true and that's how we got hello. Okay. Now after all this, if you try to print, if you try to print the value of x, let me print the value of x after this x is equal to 5. Your x is changed to 5 because we are assigning it. Most of the times we think that no, you have to give a double equal to, otherwise there is an error. No, you can give any kind of valid expression. This is a valid assignment statement where we are trying to give 5 to x. So at this point, x is assigned 5 and we get 5 here. And this 5 is a non-zero values. That's how we get hello. And then when we go to this part, your x is no more 10 but 5 because here we have assigned 5 to it. Okay. Now, let me change this x is equal to 0. Okay, 1290, did I answer your question? So, hi, it is, yes. So, x is assigned with a value 0. So, as a result, we get a 0 here, and which is 0, false. So, we go to the else part, printing high. At the end, x gets a 0 because we assigned x is equal to 0, we said. So, x gets 0 and we get high as a result. Now, what if I have double equal to there?
Hi, ma'am.
Hi,
Hi,
ma'am.
ma'am.
There is no doubt, right? What about the value of x?
10.
10, ma'am.
10, ma'am. 10,
10
ma'am.
itself. Good. High and 10. So there is no doubt in that. Very good. So altogether, these are the things that you have to remember. If can take any valid expression and if tries to pull out the Boolean value out of that expression. And how does it do it? It has a convention that any non-zero is true and 0 is false. So that's how it tries to pull out a Boolean value out of any valid expression given within the parenthesis of f. Understood?
Yes, ma'am.
So now I'm erasing this part. Now let me change it a bit. X into 5.
Hello.
Hello. And what about the value of x?
10,
10
ma'am.
only. 10, ma'am.
10. Okay. Hello and 10. Right? Let's see. Hello and 10. Good. Because this is 10 into 5, 50, non-zero, true. So hello. And we didn't assign that value to x. So x is not changing. Yeah, very good. That's a keen observation. I gave you this example just to make sure that are you following it, like this is not an assignment. So I just wanted to check it. Yeah, you passed. That's great. Good observation. Now, forget about x for a while. Let's take 10, comma 15. Can I write like this? I can write 10. That is what we have seen right just now. I can write 10 or I can write 15. But can I write 10, comma 15 there? Did you ever see such kind of practice? Yes, good, Harshini. So, Harshini, can you tell me what happens in this program? Let's forget about x for a while. So, I'm removing this part x. Ashini, since you saw this kind of practice, can you tell me what can be the possible answer? Anybody else? Hello. Okay. Hello. No surprise. Good. So we can give a series of expressions separated by commas. Within if, we can give a series of expressions separated by commas. Yes, we can. But what happens as a result? Let me give a 0 there. Can anybody guess what happens?
Hi, ma'am.
Hi. Okay. Very few answers. Is everybody online? Am I connected? Hi. Hi. Okay. Good. Let me run the code. Yeah, it is hi. Now let me change the code. Let me not come to a conclusion right now, but let me continue. Now this time 0, 10. I changed it a bit. 0, 10. This time,
Hi, ma'am.
hi, hello. There is a mixed response. Hi and hello. Okay, let me run the code. Hello. Now you can come to a conclusion. When a series of expressions are given, whichever is the ultimate expression, the truth value of that expression is taken. In the previous example, in the very first example, it was 10, 15. So 10 is ignored and 15 is taken. Now 15 is true, so we got hello, if you remember. And next time we gave 10, 0. 10 is ignored and 0 is taken. Since 0 is false, we got hi. Now we gave 0, 10. Now as a result, 0 gets ignored and 10 is considered. Since 10 is true, we get hello. Okay. Altogether, the final expression in the series is considered. The final expression in the series is considered. Okay, so this is the takeaway. Yeah, you can have a series of expressions separated by commas. Now, what happens in that situation is the last final expression in the series is taken. So somebody asked before value of comma will be evaluated and discarded, and after value of comma will be, yes. So once it is taken and evaluated and discarded, because if I'm doing something like x is equal to 0, that happens and it is put aside and 10 is considered. So that's how, yes, Harshini, that's correct. Good. So that is how if works. Altogether, if can take any valid expression, that expression is shrinked down to a Boolean value. Apart from that, if can take a series of expressions separated by commas and only the final expression is considered to evaluate true, false values. So that's for conditional, just here.
Once tell again, madam, how the value of 0 will be discarded.
89. Okay, let me put all this aside. Before in the very beginning I asked you a question like x is equal to 15. If I do this and try to print the value of x, what happens? Will it be 15 or 10 itself? 15, sure, right?
Yeah.
And now if I have just x plus 15 and try to print the value of x, what happens? 10 or 15 for x? 25. 25?
25.
Yes, ma'am.
Observe that carefully. I
10,
wrote
ma'am.
x plus 15.
10, ma'am.
It is just 10 because I did not assign x is equal to x plus 15 changes the value of x. Even mathematically, if you try to assign a particular value, then only changes happen to this variable, right? So if I write just x plus 15, that won't change the value of x. Remember that. Is that clear first?
Yes, ma'am.
Good. Now, coming back to this question, your question, what happens here is 89 is there. Okay, 89 gets evaluated and then discarded, because if I'm trying to assign it to something, it takes it and goes away. Then also it goes away. Then this is taken. Okay, so whatever is there before comma gets evaluated and gets discarded, and the final one stays there. Okay, let me run the code. So 89 is actually given to x. Print. Everything is evaluating. It's not like it is just like that discarded. No, it is evaluated. And if there is a proper assignment, they get those proper assignments. But only the final value for this particular block is considered. Okay. It is not 89 that is considered for this expression, but it is 10 that is considered for this expression. Let me write x is equal to 0. When I run the code, I get hello. Because x is assigned, 0 is assigned to x, that happens of course. Now it is kept aside and the latest value is 10. This latest value is considered for this block. So since 10 is true, we get hello, and x is already changed to 0 here. So x gets 0. Is that clear? Okay, good. So somebody asked like initially x is equal to 0 and then if 10 comma 20. Let me tell you the value of x when I give 10 comma 20 or 20 comma 10 here, it has nothing to do with the value of x. Am I mentioning the x value anywhere here? No. So it has got nothing to do with this expression. It is pure value. It is a pure value series. It has got nothing to do with value of x. I think I answered your question 12-18, Pratyusha. Okay, good. Now x is equal to 12 and x comma 10. So x gets 12 and then for if only 10 is considered. X gets assigned 12 but 10 is considered for if. Is that clear? 411? Did I answer your question? Good. Okay. Good. So these questions remind me of something, and let me take you back to assignments. Let us take a variable called x and let us assign a value 10 to it and then try to print the value of x. Seems silly, right? What will be the value of x now?
10.
10, ma'am.
10, ma'am.
Silly, right? Say yes, no problem. That's silly. Seriously.
Yes.
Yes,
Seriously.
ma'am.
Yes. Now, making it a bit more serious. What if I write 10 comma 20? All right. Can I write this in the first place? Can I write such kind of statement?
No.
No, right? But I wrote it. What happens? Will it raise an error?
No, ma'am.
If it is not raising an error, what it might be doing?
List. It is syntax.
It's only assign the value of 10 to x. ma'am.
Let me run the code for a while. For you.
X is equal to 20.
X is equal to 20. Okay, most of you said 10 and then 20. It is okay. It is dangling between 10 and 20. It is 10. It is 10. Okay. So no matter how much long series of values you mention, only the first value is considered. Let me involve 0 also. 0 has nothing to do, but let me involve it. And let me involve even negative values. Okay. So when I run it, no, nothing matters. Only the very first value matters. Clear? Near to assignment operator, that's great, good. Near to assignment operator, it takes the first one itself. Yes, very good. Somebody said it right. Near to assignment ఏదుందో దాన్నే తీసుకుంటుంది. Okay, clear?
Yes, ma'am.
Yes, ma'am.
Okay. Moving on, let me make a slight change to this assignment. I'm just trying to put everything into parentheses. Now, can you guess? Is it going to be same 10 or 20 or 0 or minus 45 or something else?
Error.
Error. Okay, let's see. Invalid, somebody said Pallavi. Come on, think about it. You need not be right always. No, you have to go wrong to learn new things. So going wrong is a must. So go wrong. 78. Somebody said 78. Yeah. People started saying 78.
Last value.
Last one.
All the numbers.
All the numbers. Okay. Let me run the code now. Time to run code.
minus 45.
It is 78. It already gives you a clue if you can connect it. What happened with if? Only the last member in the series is considered, right? So here also same thing happens. When you parenthesize things, the last one in the series is considered and that is assigned to X. Okay, 78 is actually repeating. That's just a coincidence. Only the last one. If I have a 0 there, then 0 is considered. Okay. So you have to observe this. When there is no parentheses, when you run this, the value that is nearer to the assignment operator is considered. That is the very first value in the series. And things get drastically changed when you parenthesize this part. So what happens with this part is it takes the final value in the series. Agreed?
Yes.
Yes. Good. Now, let's say we have two variables, X and Y. Let's try to assign two different values for X and Y, 10, 20, and try to print the values of them. Can you guess the output?
Ten,
10 and 20.
10, 10 and 20. 10, 10. Okay, let me run the code. Zero and 10. Let me tell you why X got 0. Forget about this output for a while. This is a very latest compiler that is tricking with you. In fact, to say you cannot write such kind of assignment statements in C. Of course, compilers are drastically getting evolved and they are becoming more and more powerful day by day. But we are going to consider the ideal compiler itself. So according to that compiler, writing this kind of statements is not really correct. Okay. We will come back to this point why X is equal to 0 and Y is equal to 10 later. But remember that such kind of assignments are not allowed. Okay, we will definitely come back to this point. That's an in-depth explanation, so I'm not touching it right now. Okay, so that is about assignments. Okay, let me give you one more Now this time, this might seem a bit silly for you, but let me ask you this question. What if I try to print the values of x and y now? X and y.
Both are 10.
Both are 10, right? Good. Because the assignment happens from right to left. This 10 is given to y first, and then that y's value is given to x. It's not 10 that is directly given to x, but it is the value of y that is given. Actually, it happens like this. For those who couldn't understand, this 10 gets assigned to y, and that y is assigned to x. So that's how when you run the code, you get 10 and 10. Now, tell me what happens now.
Ten, 10.
10, 10.
10, 10, okay. Ten, 10, because yeah, now you people understood it.
Near to assignment.
Ah, that's great.
Nearer to operation.
That's great. And now,
2020.
2020.
2020.
let me run the code. That's great. That's great. That means you understood the concepts well. Yeah. Correct. Now moving on. Let me. Yeah. Yes, dear. Your voice is not clear. Can you please repeat it once again?
Can you please explain once more? X comma y equals.
You want me to
Output is
repeat
0,
this?
10.
You want me to repeat this one?
No, ma'am. X comma y equals to 10, 20. Ma'am.
X comma y is equal to 10, 20 is not actually a valid statement in C. If you consider the C's compiler, not the very latest one like this, but if you consider the old compilers, writing x comma y is equal to 10, 20 is not really allowed. In some other languages, x takes 10 and y takes 20. That is valid. But in C, giving two variables here in the left hand side of the assignment is not correct. So what it demands is assignment expects exactly one variable on LHS. So this is assignment statement, and we have two variables in the LHS, which is not valid. So if it is asked you in examination, exam lo meeku kanaka adigite oka bit edaina oste, this kind of assignment is not valid, but it gives you this 1 0, 10. Why this 0, 10? We'll deal with this later when we get into deeper perceptions. I'll definitely touch upon this point, but not right now. Okay, clear?
Yes, ma'am.
Okay. Anything else from anybody?
Ma'am, x equal to y equal to 10, 20.
Wait a minute.
Run.
Yeah, tell me dear, x equal to?
X equal to y equal to 10, 20.
Okay. You understood this part, right? Let me remove x for a while. And did you understand this part? Can we write
10
like
is
this? So why in this situation, y gets
10.
10. There is no doubt, right?
Yes, ma'am.
Now let me add this x now. X is equal to. So this is a whole expression which has got two parts in it. The first part is this one. And the second part is this whole thing. Okay. Let me annotate. So this is the first part and this is the second part. And if you consider the first part, this is syntactically correct. Assignment operator has got exactly one variable on the LHS part. And you already understood this part. So y gets 10, right?
Yes, ma'am.
So the value of this whole expression is 10. Okay. And this 10 gets assigned to x. That's
Ma'am, you said that parenthesis is there, then the last value is considered. Now
very,
here 20
very
will
good.
be considered.
But what you have to observe here is I didn't parenthesize this part. I didn't parenthesize this part.
Okay, okay.
Got it? See this? I
Yes.
didn't parenthesize, right?
Yes, ma'am.
In fact, I didn't even parenthesize this part. These parentheses I gave you just to make you people understand that. That's it. Is that clear?
Yes, ma'am.
Yes, ma'am.
Now, if I exclusively parenthesize this part, this gets evaluated. This whole part gets evaluated to 20. And then this 20 gets assigned to y.
Y.
Yeah. Y. And that y gets assigned to x. That's how it gets reduced. Okay.
Ma'am, can you once again explain why x equal to 0?
Why x is equal to 0? That is what I said. Hold on this. Hold on this. I'll tell you later when we cover loops also, because this has got a deeper perception to understand how compilers are working. So I just hold it for a while. I'm going to hold it for a while. We'll no, definitely unveil this one. Okay. Yes. Okay. Anything else?
No, ma'am.
Okay. Now, rotation here. Let me take while 56. Mute yourself, please.
symptoms ఉంటున్నాయి
Mute.
కదా మమ్మ
Somebody.
నెగటివ్ వచ్చిన సిమ్టమ్స్ ఉంటున్నాయి కదా అదమ్మ పని
Okay. So can anybody tell me what will be the output? Forget about x and y. It will be misleading. Welcome.
వెల్కమ్
Okay. Only welcome or anything else?
Only welcome.
One time?
Yes, ma'am.
See how many times I got? People just woke up now.
Infinity, ma'am.
Yeah. Good. You thought it like if 56, right? Right? That's how you said one welcome, but it is a loop. Be careful. So things will be misleading. One has to be very keen about reading the code. This is one of the examples. You have to be very careful. But why infinite loop? Because
No condition.
True.
Condition is always true.
Condition is there. Condition is there, and condition is, yeah, somebody said it. Condition is always true because it is 56 always. So 56 is always true. So it goes on repeating itself. Right. Good. Now, what if I don't give anything at all? Asle ibbలేదు. Why everybody is so silent? I did not mention anything within the parentheses of while. Error, infinite times. Okay, let me run the code.
Nothing will be printed, ma'am.
Okay. 0. That's an error. That's an error. Okay. So don't think too much. Okay. Now let us explore for loop for some integer c is equal to 1 and c less than or equal to 10 and c plus plus, and then we have print the value of c. Silly, right? But what will be the output for this?
1 to 9.
1 to 9. 1 to 10.
1 to 10, ma'am.
Yeah. 1 to 10.
1 to 10.
So that's a very silly question to ask, but we always have to go from silly to serious. So I took this. Then let me take plus plus c. 10.
1 to 10. 10 to 1.
10 to 1.
1 to 10. ma'am.
1 to 10, ma'am.
1 to 10. ma'am.
Okay, let us run the code and see. 1 to 10. See, writing plus plus c or c plus plus is not going to make any difference in this particular situation. Okay. Now, let me cut this statement from here and let me place it here. Can I do that?
Yes, ma'am.
Can I do that? Somebody said yes. Yes, we can do that. If we can do that, assume that we can do it. You assume that we can do it. Now tell me what will be the output.
One and 10.
1 and 10 or 1 to 10 or something else?
1 and 10.
1 and 10. Okay. Only 1. 1 to 10. 1 to 10. Let's run the code. 1 and 1 to 10, somebody said. That is 1 to 10. See, there are...
But
no.
printf is before the increment operator, no, ma'am.
Yeah, before incrementation, 1 is already there, right? So 1 gets printed and then incrementation happens 2 and then it goes to this one. It's not like 1 gets printed for 2 times. No, 1 gets printed and then immediately gets incremented to 2. Then we go back to the condition. So 2 is checked against 10. Is that what you're asking for? Hello, make some noise. Okay. So for loop has got 3 parts in it. Part 1, part 2, and part 3 with semicolons, right? And whatever we want to write within this block, we can write within the block, right? And part 1 talks about initialization, and part 2 talks about condition, and part 3 talks about increment.
Increment or decrement.
Right. So this is how we learned, right? Avuna? ఇప్పుడు వరకు నేర్చుకున్నది మనం ఇది. But taking you back, your part 1 with a semicolon, part 2 with a semicolon, part 3 with a block. So coming to this particular part 1, you can write any number of instructions with separated by comma. Okay. You can in fact write any number of instructions separated by comma. And the same is true for this part also. In fact, it is true for this part also. Nijam cheppali ante. Okay. So let me annotate. So this is one part, and this is another part, part 2, and this is part 3, right? You in fact, మీరు ఎన్ని instructions అనేది, this is an example for that. You can write any number of instructions in any of the parts, these 3 parts. But only thing that you always have to remember is the first part happens only once, for the very first time when we are entering into the loop. Okay. Coming to the second part happens every time. It happens every time. Every time whenever we are trying to enter the loop once again. So every time. And this part also happens every time. Idi every time jarugutundi, idi every time jarugutundi. But what makes the difference? Idi condition check cheskuntamu. Idi ante idi beginning lo jarugutundi. Idi exit time lo jarugutundi. So before you exit, part 3 happens. Before you enter, part 2 happens. But only for the first time, part 1 happens. These timings are very important to remember. Now, did you understand which part happens when?
Yes, ma'am.
Yes, ma'am.
Okay. It is only then we can understand the intricacies of this for loop. For loop is a bit trickier. మనం ఎలా చూస్తామంటే దీన్ని ఓన్లీ ఇనిషియలైజేషన్ మాత్రం చేయాలి, ఇక్కడ కండిషన్ మాత్రమే జరగాలి, ఇక్కడ డిక్రిమెంటేషన్ మాత్రమే జరగాలి అన్నట్లుగా చూస్తాము దాన్ని. బట్ ఇన్ ఫ్యాక్ట్ ఇట్ ఈస్ నాట్. ఓ సారీ, లెట్ మీ ఎరేజ్ ఎవ్రీథింగ్ వన్స్. బట్ దట్ ఈస్ నాట్ ద ఫ్యాక్ట్. ద ఫ్యాక్ట్ ఈస్ బేసిక్ లో లెవెల్లోకి వెళ్ళి చూస్తే we don't have literal initialization, literal condition checking, incrementation, decrementation part. No, this is a trash. Frank ga matladali ante. And this is the truth. Idi nijam. So దీన్ని మనము ఒక కన్వెన్షనల్ వేలో మార్చి ఇందాక రాసినట్లుగా ఇలా రాసాం అంతే. కానీ దాని యొక్క వెరీ బేసిక్ నేచర్ ఎలా ఉంటుంది అంటే ఇలా ఉంటుంది. యూ కెన్ రైట్ n number of statements in each and every part. All are separated by commas అన్నమాట. So let me give you demonstrations one by one on each of the parts. Let me take c is equal to 1 and let us take two variables, integer x and y. Okay, so as I told you, let me do some operation like x is equal to 10 plus 20 comma y is equal to x. Okay, instead of taking direct x, let me say some 39 or something like that. Okay, now here, as I told you, any expression is okay. Any expression is okay, right? So let me give some 12, just like that. And let me take another example. As I told you, any number of instructions, I'm going to take 0 number of expressions here. So altogether, my no annotations, please, by anybody. Okay, so this is the first part, this is the second part, and this is the third part where I didn't write anything. Any number of instructions mean 0 also. Okay, remember that point. 0 instructions kuda rayachu. Any number means including 0. Okay, so that's it. That's all. I don't want to write anything else. So I just ended it with a semicolon if you observe. I can do that. We can do it. We can end it instead of taking parentheses, curly braces. We can actually end it up there itself with a semicolon. So what happens as a result? If we want to see the results, what we have to do is we have to print the values of x and y. New line, another percentage t, another percentage t, the value of x and the value of y. Instead of taking 12, let me take 0 because it's going to take me to infinite loop. You all know that, right? When I run the code, my loop ends for the first time itself because in the conditional part, I have a 0. 0 means false. But I have got this 30 for x and 39 for y. How did it happen? Because as the rule says, for the very first time when we are entering into the loop, the first part must happen. What is happening in the first part is we are trying to assign some values to x and y. So as a result, x has got 30 into it and y has got 39 into it. Now coming to the second part, the conditional part, we gave a 0. Since that's a 0, we don't enter into the loop. Of course, we don't have anything in the loop. Even though if you have it also, let's say we have some printing part like welcome, let's say printer welcome. So even though we have something, it will not execute because we have a 0 there in the conditional part. Since there is a 0, we come out of the loop. Now after coming out, we have 30 for x and 39 for y. So that's how your expressions get evaluated. So there is no strict rule involved in for loop that ikkada initialization maatrame jaragali, loop ki sambandhinchina things e jaragali, other nonsense jaragakudu, nothing. There is no such rule at all. Did you understand?
Yes, ma'am.
Understanding this fact is very important because for loop can be the trickiest part. It can trick you just like anything else. Okay. So let me know if you have any doubts about it. We will clear all of those doubts here itself and we'll move on to explore more about for loop. Ma'am, why welcome is not printing? Because as I told you, this is the first part. Before first semicolon is the first part. In between is the second part where we write the condition. And within that condition, I just mentioned 0. 0 means false. That means for the first time itself, the loop failed. So that's how we are not entering into the loop at all. So that's how we did not get welcome printed on screen. Is that clear?
Yes, ma'am.
Okay, good. Once place 12, yeah, I'll place 12. Now you have to tell me what happens when we place a 12 there instead of 0.
Twelve times.
12 times.
Infinity number of times. ma'am.
Infinite.
That's it. Good, good. This condition, this is the conditional part. You can give any nonsense there, but remember that that's a condition and it gets evaluated every time. And it is always 12, that means always true. So it goes on and on. So let me print it. Let me run the code. We get welcome for infinite times. You will never come out of it because the condition itself is always 12, always true, always keep happening. Is that clear? This doubt is from Vivo 1606. Is that clear? Okay, good. Anything else from anybody?
No, ma'am.
Okay. Then I'm going to stop this discussion here itself.